Hi students, today we'll discuss the input and output organization. So this is the last topic of the computer architecture course. The books which will be referred to complete this particular topic are given as reference. So till now we have discussed that what is a CPU, what are the different internal blocks of the CPU, how the CPU can be interfaced with the memory, what are the different types of the memory, how the addresses can be assigned to the memory, or how the data can be transferred from the cache memory, primary memory and secondary memory. All these things we have already discussed in the previous lectures. Now we will move to the another part which is a mandatory part of the computer. If we look at the block diagram of the computer, then we will find that input and output devices are also the important part of the computer, which are used to provide the input and to take the output. The input and output devices are also the important part of the computer. Input devices are used to provide the input to the processor. After the manipulation or processing, the data will have to be, if the data will have to be displayed on the output device, then it will be displayed on the output device. In this particular chapter, we will try to understand how can we interface the different input or output devices with the microprocessor or with the CPU. What are the different technologies, what are the different methodologies are used to interface the input output devices with the CPU. As we know that in a computer, we will be having so many input and output devices through which we will have to supply the input to the processor, or we will use to display the result whatsoever the result will be processed or manipulated by the processor. If we want to display, then that will be displayed through the output devices. So this particular diagram is showing a processor, memory, along with the different input and output devices are interfaced or connected to the processor. Now, through what type of buses these I/O devices will be connected to the processor? More than one I/O devices will also be connected to the processor through a set of three types of buses. As we know that the different types of buses are required to interface the memory with the processor, and a similar bus structure will be used to interface the I/O devices with the processor. Address, data and control buses are required to assign the or to interface the different I/O devices with the processor. So on this, by using the similar way, as we know that the each and every memory location is having its own and unique address, and similarly each and every I/O devices also required a unique address. Even if a one device will be having more than one ports within that particular one I/O device, then for each and every port there is a need to assign a unique address, so the data of that particular port can be transferred or received by the processor by sending the address on the address lines. Now we will try to understand what are the different techniques or methodology which are used to map the I/O devices with the processor. There are two types of mapping techniques, and these mapping techniques are known as memory mapped I/O and I/O mapped I/O. So in the next slide, we will try to understand what are these two different methodologies or different two techniques. Here we can see that the different two different techniques which used to assign the addressing to the I/O. First one is known as memory mapped I/O and second is known as I/O mapped I/O. In case of memory mapped I/O, the whole addressing capacity of a processor will be divided into two parts. One part will be reserved for to assign the address to the input output devices, and another part of the addressing capacity will be used to assign the addresses to the memory space. So here in this case, a similar or a same addresses or same addressing range will be used both for memory as well as for the I/O space. So by using the similar set of instructions, there is no need to assign the separate instructions for the I/O or for the memory. Similar or same instruction can be used to access the data from the I/O as well as from the memory. If we will send the address by using one instruction, say we want to load the data of 00000, even if we will write the instruction load R0 0000, then what it will do, it will read or load the data of an input device whose address is all zero. And on the other hand, if we will use the same instruction by changing the address, any address in between this particular range, then the data will be moved from the memory. So I will try to compare it with an example. Say in any educational institute, if hostel accommodation will have to be designed, then there are two ways to assign the hostels to the boys and to the girls. One way is we can develop or design the different blocks for the boys and girls, and can assign the different addresses to the boys hostel and different addresses to the girls hostel by writing a prefix. Say G is for girls, G101, G102 means girls hostel 101 room number. And on the other hand, if we will go with B101 and B102, the meaning of this is that this is belong to the hostel of boys. So this particular technique will be used in IO map dial, so in which the different addressing capacity will be reserved for the memory space, and another set of addresses will be reserved for the IO space. And if we try to compare the similar example with the memory map dial, then it means if let's suppose we are having a 1000 rooms, we will generate the 1000 addresses, and first 100 or first 200 will be allotted to the girls hostel, and from 201 to 999 will be allotted to the boys hostel. So if we will call the student room number 100, if we will call the student of room number 100, then naturally this particular address is allotted to girls hostel. So the girl student will be called, and if we will call the students of if we will call the address of say 500, then naturally the boys, that 500 is belong to the boys, so naturally the boys will be assessed. So okay, so these are the two methodology. If we will use the same instruction with a different addressing range, then it will be called memory map dial. And if we will use the two different set of addresses, then naturally we require the two different set of instructions as well to access the data, because we can see that one set of address is there in memory space whose address is all zero, and another address of IO is also there whose all bits are is equal to 0. So two different addresses are there with all equal to 0. So we will have to use the different addresses, a different instruction to access the data from the memory as well as from the IO space in case of IO map dial. But in case of memory map dial, we will use a different range. We will use the different range to assign the address to IO as well as to memory. So this particular whole capacity can be accessed through the one set of instructions. So this is all about the memory map IO. Now we will try to understand how we can assess the IO. Normally the data transfer rate of the IO devices is slower than the speed of the microprocessor. As we know that the processors, the data transfer or data handling speed is in gigahertz, so it will be in nanoseconds. But it is not possible to develop or design the IO devices in such a way that which can be operated on such a high speed. If so, if we will be having the IO devices whose operating speed will be equal to the operating speed of the processor, then such type of data transfer schemes are known as the synchronous data transfer scheme. So in case of synchronous data transfer schemes, when the operating speed of the processor will be matched to the operating speed of the IO devices, then there will be no problem. Whenever processor want to access the data will be ready within the IO device. It can be accessed by sending the simply control signal. But what will happen in those cases when the speed of the IO devices will be slower than the speed of the CPU? then such type of data transfer schemes are called asynchronous data transfer schemes. So in case of asynchronous data transfer schemes, there is need to create some sort of mechanism which must be used to synchronize the data transfer between the processor and I/O. Okay, and first scheme is known as programmed controlled I/O. First scheme is what? Program controlled I/O. In case of program controlled I/O, the processor we will have to write the program in such a way that processor will continuously check the status of the I/O devices, from where it want to read the data or to whom it want to send the data, either that particular device is ready or not. Once it will receive the signal from the device that particular device is ready, then and then data will be transferred. Otherwise, it will wait for the readiness of the device from where it want to read or write the data. So this particular technique is called polling. This is called polling. So we can understand this particular technique from this particular simple diagram. Within the program, what will happen? It will check, the processor will check, is the data ready? So it will check or send a signal, or will continuously check the device 1, 2, 3 or 4 from where it want to read or write the data. It will check the status of that particular device. Whenever that particular device will ready, it will read the data and store the data, and then once the process will over, then it will come out of that. Otherwise, if the data will not be ready, means if the device will not be ready to deliver the data to the processor, then what it will do? It will go again and check it again. If I will try to compare it with an example, say you are having a mobile phone, and if your mobile phone will be on silent, then what will you do? And say at the same time you are reading a book, so what will you do? Then it will be your responsibility to continuously monitor that particular mobile phone. After the completion of one line, after the completion of one page or whatsoever, the minimum or maximum time duration you will fix to continuously monitor that particular mobile phone. If you are expecting that some sort of phone call, if you are expecting some sort of phone call through that particular mobile phone, so then it will become your responsibility to continuously monitor your mobile phone. Okay, as soon as there will be a call on the mobile phone, you cannot listen the ringtone as your phone is on silent. Then once you will see, by monitoring it, by checking it, if you will see that now the phone call is there on your mobile phone, you will pick that particular call and respond accordingly. Similarly, CPU will continuously monitor all the devices. Whenever a device will be ready from where it want to transfer or receive the data, immediately after it will send the control signal to read or write the data from or to that particular device. Okay, so this particular process is called polling. This particular process is having so many disadvantages, and main and big disadvantage is it is time consuming. So for polling process, the processor will remain busy to do a fatigue job, that is to check the readiness of the data. This is not the responsibility or duty of the processor, just to wait and check the data or readiness of the data from that particular I/O device. So that is why this particular technique is not popular for the large systems in which CPU will have to perform so many tasks at one time. Okay, the other two mechanisms which are used to synchronize the data transfers between the processor and memory are interrupt driven, and third one is the direct memory. In case of interrupt driven, it will be the responsibility of the I/O device to send a request to the CPU whenever the data will be ready within that particular I/O device, or in other words, we can say that the readiness of the data of any I/O device will be sent by the device to the CPU, that the data is ready with me, now you can read and write the data. And during that particular period, whenever the I/O device will make ready the data, CPU can perform any other task. Okay, and in third one is the direct memory access. In direct memory access, it is used for the bulk data transfer from IO to memory or memory to memory. So it will bypass the CPU whenever it will perform its operation. It will bypass the CPU. So these two techniques we will discuss in the next two lectures. Thank you.